Welcome. In this lecture, which has multiple sessions, we'll explore stationary and convexity for a function that has a scalar argument. The main concepts in this lecture are stationarity, what a minimizer is, what a saddle point is. We'll examine a first-order condition, we'll look at a convex function, and we'll briefly introduce the gradient inequality. We'll continue in our sample problem from the previous lecture, and we'll look at the step response of a simple dynamical system. Let's review some of the basic assumptions around a function. Unless we state otherwise, it maps a real number to a real number. We're going to assume that it's continuous, and you can refer to calculus material to get the exact definition. It'll be differentiable, which means that the limit definition for differentiability applies everywhere, and we won't have functions that are, for example, differentiable only on one side. So continuously differentiable is what we'll mainly look at, and what that means is it's not just continuous, it also means that the derivative is a continuous function. And we may occasionally need to restrict our functions. For example, in our dynamical system, because we're assuming that t somehow maps to time, a negative time doesn't make any sense. So in that case, we're going to restrict the domain of the function to be non-negative real numbers. Now, let's review our dynamical system. When we suppose that we start it at a t1, which is a first estimate, at 0.14 and 0.08. Our function was originally limited to 0 to 0.60, so that wouldn't seem automatically to be a terrible difference, would it? Well, if we start it at t equals 0.14, what we get is a convex function as our estimate when we provide it with the point, with the first derivative, and with the second derivative. Suppose that we deviate that ever so slightly. What we find is that the function is now concave, or the convexity is pointing down. So this dynamical system near this point is quite sensitive if we use a particular polynomial approximation. One of the questions that we'll try to explore in this lecture is, why does the estimated minimizer diverge so much?